Welcome to my YouTube channel. Today we are going to discuss about strength of an acid or a base, universal indicator and pH scale. To begin with, let's know about strength of an acid or a base. When we dissolve an acid or a base in water, then there is the formation of hydronium ion or hydroxyl ion in water, and dilution causes the decrease in the concentration of these ions. But can we say which acid or base is more stronger than the other? Is there any way by which we can say that any acid is more stronger than the other acid or a base is more stronger than the other? In order to know whether a solution is acidic, basic or neutral, we use different types of indicators like blue and red litmus paper, phenolphthalein, methyl orange, etc. Similarly, to know the strength of an acid or a base, we use universal indicator. It is a mixture of many indicators. The universal indicator shows different colors at different concentrations of hydrogen ions in a solution. Universal indicators are available in solution form or as pH paper strips. What do you mean by a strength of an acid? The strength of an acid is defined as the concentration of H plus ions in its aqueous solution at a given temperature. Acids that give rise to more hydrogen ions are strong acids, whereas acids that give less hydrogen ions are said to be weak acids. Some examples of strong acids are hydrochloric acid, sulfuric acid, nitric acid, etc. Some examples of weak acids are acetic acid, oxalic acid, lactic acid, etc. What is the strength of a base? The strength of a base is defined as the concentration of OH minus ions in its aqueous solution at a given temperature. Bases that give rise to more OH minus ions are strong bases, whereas bases that give less OH minus ions are said to be weak bases. Some examples of strong base are sodium hydroxide, potassium hydroxide, etc. Some examples of weak bases are aluminum hydroxide, magnesium hydroxide, etc. For measuring the concentration of hydrogen ions or hydronium ions in a solution, we use pH scale. The range of pH scale is from 0 to 14, and 0 being very acidic and 14 being very alkaline. 7 is the pH of a neutral solution. pH 0 is very acidic, whereas 14 is very alkaline, and pH 7 is neutral. This means that acidic solutions have pH less than 7. Higher the concentration of hydronium ion in a solution, lower is the pH value. For example, an acid with pH 3 is more acidic than an acid having pH 4. For bases, on the other hand, the pH increases from 7 to 14 as it represents the increase in the OH minus ion concentration. Therefore, a base with pH 10 is less basic than a base with pH 12 or 13. Now, let us see the use of universal indicator, and with the help of a pH paper, let us determine the pH value of some of the solutions that I have taken. I am taking the pH paper by which I I am going to determine the pH value of few solutions. Let us take the first solution. Now I am going to dip this pH paper to it and see the color change. Here you see that it has turned blue. That means it is alkaline. Now let us try to match the color of this pH paper with the pH scale. So the color matches with the corresponding pH value 10. That means this solution is a weak base. Let us take the next solution. Here you see that it has turned orange. Now let us try to see the pH value of this solution. So the color is matching with the corresponding pH value 1. That means this solution is a strong acid. Moving further, let's see the pH of the next solution. Here you see that it has turned blue. That means it is basic. Now we are going to match the color with our pH scale. So the color is matching with the corresponding pH value 12. That means it is a strong base. Similarly, we are going to repeat the same procedure with the next solution. Here you see that our pH paper has turned pale green. And it is matching with the pH value 7. That means this solution is neutral. In this way, we can use the universal indicator and determine the pH value of the given solution. Let us discuss the importance of pH in our day-to-day life. First, narrow range of pH for living organisms to survive. Living organisms survive in the narrow range of pH. Any drastic change in the pH is harmful for the living organisms. Human body functions well in the narrow range of pH between 7 to 7.8. Pollutants such as carbon dioxide, nitrogen dioxide, sulfur dioxide, they mix with the rainwater and form corresponding acids. This phenomena is known as acid rain. And this acid rain, when it reaches to the river water, it makes the river water acidic, which is harmful for the aquatic organisms. Specific pH of soil for plants growth. Specific pH of soil is required for the proper growth of plants. Plants cannot tolerate the drastic change in the pH. Let us find out the pH of the soil which I have taken from my garden. I have already prepared the soil solution and now let us test the pH of this garden soil with the help of a pH paper. Here you can see that it has turned yellowish green. Now let us try to match this color with the pH scale. So it is matching with pH 4 in the pH scale. That means this soil is acidic in nature. pH in our digestive system. Stomach produces hydrochloric acid which digests our food. But during indigestion, excess acid is produced which causes pain and irritation. We take antacid like magnesium hydroxide, commonly known as milk of magnesia, which is a mild base that neutralizes the acid present in the stomach and relieves us from the pain. Tooth decay due to change in pH. Our tooth enamel is made up of calcium hydroxyapatite, which does not dissolve in water. However, it starts decaying at pH lower than 5.5 in the mouth. Acids are produced in the mouth due to degradation of sugar and food particles present in the mouth by the bacteria, which lowers the pH of the mouth and causes tooth decay. Therefore, brushing our teeth with basic toothpaste and maintaining oral hygiene prevents tooth decay. Self-defense by plants and animals. Stings of honeybees, wasps, bumblebees contains acid which causes pain and irritation. Baking soda, which is a mild base, is applied on the stung area to get relief from the pain as it neutralizes the acid. Plants like nettle contain stinging hairs on the leaves that contain methanoic acid which causes pain and irritation. Thank you for watching my video. I hope you enjoyed it. Don't forget to hit the like button and subscribe my channel.